For the first time ever, I am thrilled to say we have an official sponsor for the Dirt Talk podcast, and that's Ariat. I've worn Ariat boots on every job site I've visited over the years, traveling in them across 5 continents. More importantly, I have yet to find a single project where working folks, unlike me, are not wearing Ariat boots and workwear in every condition imaginable. And there's really good reason for that, and that's because it's phenomenal stuff. And the more I've learned about Ariat and the company, the more I've loved their brand. So with this, Ariat is offering any Dirt Talk listener 10% off their next Ariat order at ariat.com/dirttalk. That's 10% off boots, jeans, and workwear at ariat.com/dirttalk or at the link in this episode's description. With that, let's get to the show. Hi, everybody. Welcome back. Monday Dirt Talk. It's me here, Nashville, Tennessee, in the studio. And today, we're going to talk about one of the more interesting projects, I think, in modern infrastructure history in the United States. And it's interesting for a few different reasons. One, because it's a very complex, pretty cool project to begin with. But two, it went really, really wrong. And that makes it a lot more interesting too, because now, a few years after it finally has been completed, the legal disputes have been resolved, and we have some answers. So the project, to waste no time, is the SR-99 tunnel, and this is State Route 99 through downtown Seattle. So, to give you some background, I'm going to be reading from a few different articles here. The first one is from Washington Department of Transportation, dated 12/11/2019, so it's a little bit dated here. In 2001, a 6.8 magnitude earthquake shook and damaged the Alaskan Way Viaduct. Some columns moved as much as 5 inches. So WashDOT repaired and strengthened the viaduct, but replacing it started to enter the chat, so to speak. So then in 2009, Washington State Legislature passed a bill instructing WashDOT to replace the Alaskan Way Viaduct with a double-decker tunnel built with a tunnel boring machine. So boring the tunnel with a very large diameter allowed only one tunnel to be needed, and also, most importantly, allowed SR-99 to remain open during the construction of the tunnel. So in 2010, WashDOT hired Seattle Tunnel Partners, which was the design-build contractor for the project, and STP was a joint venture between Dragados and Tudor Perini, and then they also hired Hitachi Zosen to build what was at the time the world's largest tunnel boring machine, which was 57.5 feet in diameter and nicknamed Bertha. So then, tunneling started in July of 2013. But in December of 2013, the tunneling machine overheated and stopped moving forward, which is what we are going to discuss today at length. STP later discovered broken seals on the machine's main bearing. So then extensive repairs and reinforcements were completed in late 2015. And then Bertha finished mining in 2017. And the new tunnel, SR-99 tunnel, opened officially February 4th of 2019, which was roughly 3 years later than the contractor's initial estimate. And then starting middle of February of 2019, crews started demolishing the 1.4-mile viaduct along Seattle's waterfront, and demolition wrapped up in November of the same year. And if you've been to the waterfront in the past few years, it's miraculous how different it really is. Getting rid of that viaduct, it's completely opened up Seattle, because the viaduct ran along the water, but not perfectly along the water. So you had the entire waterfront separated by the viaduct, and then you had downtown. So now that you've gotten rid of that viaduct, You've gotten rid of all of that traffic through the middle of town, and you've reunited the waterfront of Seattle with downtown Seattle, which is dramatically. It's one of the most dramatic improvements I've seen in a downtown in the United States of America in a very long time, probably since one could argue the Boston Big Dig. So then, here's some background on the legal dispute. So as you can imagine, the tunneling machine failing in 2013 caused some problems and delays, which then ends up in plenty of litigation. So as the tunneling machine, after it failed in 2013, STP built an 80-foot wide, 120-foot deep shaft to reach the machine, because the problem with a tunnel boring machine is it only goes one way. And so if it gets stuck, you can't reverse it. And so what they had to do was dig a hole above where it was stuck to retrieve it. They built this massive gantry crane to then lift the large pieces of machine to the surface. And then they had to rebuild the machine. So STP requested reimbursement for repair costs and delays, but WashDOT declined, stating it was STP's contractual responsibility to repair the machine and complete the tunnel. So this was the heart of the dispute. In this design-build contract, the contractor is responsible for completing the design for the means and methods of construction. This also includes the design, manufacture, and operation of the SR-99 tunneling machine. So for those of you that don't know how design build works, WashDOT essentially goes and says, hey, we need to replace this viaduct, and we want to replace it with a tunnel. But what kind of tunnel and how we do it is open for debate. And so based on qualifications and rough numbers, we're going to choose a group, in this case, this joint venture, Seattle Tunnel Partners, to help us design the actual tunnel and then build the actual tunnel and then maintain the actual tunnel. So that's why they said, hey, this is on you, because you were the one that chose this design. You were the one that chose this machine, this strategy for building this tunnel. So everything under that umbrella is on you. And so WashDOT believed the damage to the tunneling machine was a result of inadequate design and faulty operation, which caused the tunneling machine to clog and ultimately fail. So in 2016, WashDOT sued STP for breach of contract for failing to meet the contract requirements, including completion deadlines. So WashDOT was seeking $57.2 million in liquidated damages as a result. But then STP countersued for damages, blaming WashDOT for a steel pipe in the tunnel's path. The 8-inch hollow pipe was a well previously used for groundwater testing and monitoring. STP claims the pipe damaged the machine. STP admitted in court it was aware of the well, had intended to close the well before tunneling, but then forgot to do so. Whoops. STP also sued Hitachi Zosen, the manufacturer of the tunneling machine. So just before trial, STP and Hitachi Zosen settled their dispute, and the parties kept the settlement terms private. But STP and WashDOT went to trial, and STP filed a claim with WashDOT requesting $642 million for repair costs and damages. But then the court rejected STP's claim. So it was ongoing at this time, but then if you go to the Seattle Times, dated October 14th, 2022, by Mike Lindblom, taxpayers are off the hook for the cost overruns on the SR-99 tunnel. The court's decision to decline to hear an appeal by Seattle Tunnel Partners also means the state can keep $77 million in penalties a jury had awarded the Washington State Department of Transportation for project delays. The funds will be received in the coming weeks, WashDOT said. Contractors had initially sought as much as $600 million above the $1.3 billion tunnel project contract amount, which was the largest piece of the state's $3.3 billion project to replace Seattle's old Alaskan Way Viaduct and connecting streets. So they initially requested that $600 million. So what essentially happened was WashDOT said, you owe us money because you delivered this tunnel way after you said it was going to be delivered. We have liquidated damages within the contract, so pay up. This is your problem, not ours. And then STP said, no. This is your fault because there was this pipe in the way. And you actually owe us $600 million. So jurors finally settled it. So they denied STP. They said, nope, you're not getting the $600 million. Get out of here. And then they ruled the companies must pay WashDOT $57.2 million in contract penalties for 867 days of delay, which then grew with interest to $77.2 million while they appealed. So that's how all of this ended up. And I think the legal side of this is, like I said, as interesting as the actual construction process, because this is what happens behind the scenes. You've got these projects. They have to be concluded, but litigation is an enormous part of large infrastructure projects in the United States. And one could argue it's a massive problem, which I believe it is, but other people could argue it's just a reality of doing anything in today's world and building anything in today's world. And this project was certainly a good prospect for some substantial litigation because, man, it was a pickle. So beyond the litigation, it's worth getting into some of the specifics on the tunnel and the tunnel boring machine. This is from Wikipedia, Bertha tunnel boring machine. She has her own Wikipedia page. I love Wikipedia. Design and assembly. Bertha was designed and manufactured by Hitachi Zosen in Osaka, Japan, and was the world's largest earth pressure balance boring machine at the time, at a cutter head diameter of 57.5 feet, which is 17.5 meters. The machine was 326 feet long, 99 meters, and weighed 6,700 short tons or 6,100 tons. The machine itself cost $80 million and was owned by Seattle Tunnel Partners. They held a naming ceremony in Osaka, December 12th, and then sent it to the Port of Seattle in 41 sections, and it arrived beginning of April in 2013. The machine began excavation of the 1.7 mile long route on July 30th, 2013, with completion of the bore scheduled in 14 months' time, and the tunnel opening to traffic in December of 2015. But then the pickle starts. By December 6, 2013, Bertha tunneled 1,019 feet, or 11% of the total 9,270 feet for the tunnel, stopping about 60 feet below ground between South Jackson and South Main Street. The machine's progress was halted on that day by an unexpected impediment. After a month's investigation, WashDOT announced that the machine's cutting blades had encountered a 8-inch diameter, 119-foot-long steel pipe, one of several well casings left over from a previous 2002 drilling project that had assessed groundwater conditions and soil stability in the area in case of another earthquake, such as the 2001 earthquake, which led to a need for the replacing of the Alaskan Way viaduct in the first place. Because the machine cannot cut through metal, the pipe damaged several of Bertha's cutting blades, necessitating blade replacement before the machine could proceed. The pipe locations were known to WashDOT, and the agency thought they had been removed, while STP admitted in a 2019 lawsuit that they had knowledge of the pipe prior to excavation, as we've previously discussed. So then, in early February of 2014, as Bertha was being prepared to resume operation, workers discovered it was overheating and that a damaged main bearing seal needed to be replaced. Multiple options were discussed to fix the problem, but Bertha was expected to be out of commission until March of 2015. And the project was supposed to end in 2015. In December 2014, workers began digging a 120 feet deep pit in order to lift Bertha's front end up to street level for repairs, but were delayed when groundwater pumping caused visible damage to nearby South King Street and some of its neighboring buildings. The front end of the machine, including the damaged cutter head, was successfully lifted onto the surface on the morning of March 31st, 2015. And STP estimated that fixing Bertha would delay the opening of the new tunnel by an additional 9 months to August of 2017, which was later extended to March of 2018 after additional damage was discovered in June of 2015. So they have to lift the entire machine out. And then you don't just run down to the parts store, your local Hitachi dealer. Hey, you got an extra seal for Bertha? We could use one today. It's not that simple. And then as they explain, there's a lot of groundwater in the area. You start to remove that groundwater, which then creates settlement that you have to solve for. Because that hole that they had to dig was not supposed to be there. They were supposed to be tunneling. They weren't supposed to have a hole on the surface, and yet there they were. So, in May of 18th, 2015, WashDOT reported to the Seattle City Council that the damage to the bearing and seals was worse than had previously been reported. Further inspection after the cutting head was removed and disassembled showed damage to the cutter head drive gears, so a new estimate of repair time and cost was prepared. The front end of the machine was lowered back into the access pit for reassembly in a 4-lift process, beginning with the repaired cutter drive on August 24th, 2015. And Mowat, I believe, created a gantry crane over the pit to lower these segments into the pit. And again, all of this was not supposed to happen. They weren't supposed to have to lower these pieces down into this enormous hole that wasn't supposed to be there. So the whole thing was a fiasco. Then, in June of 2015, STP sued to force insurers to pay out on the $85 million insurance policy to cover repairs needed after Bertha's cutting teeth were damaged in a collision with a steel pipe in December of 2013. In August of 2015, a consortium of 8 insurers filed a lawsuit against STP in order to avoid a $143 million payout to cover the cost of repairs to the boring machine. So they had to pay up 9 figures to do all of this, and they sued they had to sue and to get the insurance companies to pay, but then the insurance companies sued and say, no, we don't want to do that. The insurers claimed that the tunnel boring machine's capabilities were inadequate for the project and should be excluded. So no, you used the wrong tunnel boring machine, so we're not liable. It is unclear what triggered the damage to Bertha's main bearing. Problems with the seal system appear to date back to the machine's initial testing in Japan, when the seal assembly was damaged and required repairs. However, Hitachi Zosen stated that there was nothing wrong with the seals in the original machine, noting that Bertha appeared to function properly before striking the well casing. WashDOT disputed this and stated that the well casing was not responsible. So it's so wild to me, because this is a multi-billion-dollar project, infrastructure project, with some of the world's biggest companies involved. And you can have a problem like this and then have the he said, she said as a result, saying, no, the machine was already damaged when we got it. And we ran it anyway, but then the pipe damaged it. Like, no, the pipe didn't do it. No, the pipe was only that, but it wasn't. It's just to me, it's a crazy story. Okay, so on December 22nd, 2015, which is when the tunnel was supposed to be done originally, the machine resumed digging 1.5 feet through sand poured into the recovery pit. By January 4th, Bertha had traveled 1,098 feet of its planned 9,270 foot long route from Sodo to Lake Union Station. On January 6th, 2016, Bertha broke through the concrete access fault and began digging through normal soil. Digging was then halted once again on January 12th after a barge carrying excavated dirt tipped over in Elliott Bay, spilling its load and damaging a dock at the Port of Seattle's Terminal 46. The same day, a sinkhole formed within the tunnel's work zone, approximately 35 feet north of the access pit. The hole was filled with 250 cubic yards of concrete by contractors the following day and was not expected by WSDOT to delay the resumption of digging later in the week. And that's an important note of the project. The spoils from, you've got your tunnel boring machine spinning and it's removing the dirt in front of the cutting head. And it's an earth pressure balance machine. And so because it's soft material, they were boring along the waterfront. The front of the machine is under pressure. And so you've got that pressure counteracting the force of the earth wanting to fall in on the tunnel being dug. And then there's a corkscrew and there's a foam agent mixed in with the material. And the corkscrew allows the material to come out of that pressurized area without losing pressure at the front of that cutting head. And then that material can normally fall onto a conveyor belt. The conveyor belt is extended as the machine works its way further into the tunnel, and that conveyor belt transports that material out the end of the tunnel. Then that material then fell from conveyor onto barges and was transported away from downtown via barge because, again, they were on the waterfront, and transporting all of that over the road would have caused a lot of traffic around town and would have been a mess. So that's why a barge flipped over from the project. On January 14th, 2016, the governor ordered drilling on the tunnel to stop, invoking a contract clause in the tunnel agreement that allowed the state to suspend work based on unsafe conditions for project personnel or the general public. Before excavation of the tunnel could resume, WSDOT requested that STP complete and deliver an analysis of what caused the January 12th sinkhole and what modifications to tunneling operations could be made to prevent further ground level problems. Then digging resumed on February 23rd after WSDOT review determined that new soil monitoring practices were sufficient, allowing the machine conditional permission to bore through 160 feet of material and finish the initial testing phase of the machine. By March 14th, Bertha had finished its 300-foot bore to a safe haven located ahead of the Alaskan Way Viaduct, allowing WSDOT and STP to prepare for a 2-week closure of the viaduct in late April as the machine passed under the vulnerable structure while closely monitored. Following a month of maintenance and inspections, Bertha resumed tunneling on Friday, April 26, 2016, and crossed 15 feet under the closed viaduct in an 11-day closure in early May that ended earlier than scheduled. So they did something earlier than scheduled. Good for them. In June 2016, the tunnel reached its lowest point, 115 feet under Madison Street in downtown. A maintenance stop was conducted under Spring Street, replacing 33 of the cutter head's teeth. By September of 2016, Bertha had tunneled 4,635 feet, surpassing the halfway mark of the planned 9,270 feet. As of December 15, 2016, the tunnel length reached about 70%. And then tunnel boring was completed on April 4th, 2017. And the finished tunnel opened to traffic in February 4th, 2019. Practically none of Bertha's components were reusable, and most of its steel was melted down and recycled. The final disassembled pieces of Bertha were removed from the tunnel portal in August of 2017. Wild. And it's interesting to note, this was the biggest tunnel boring machine built at the time based on diameter because they needed a really big diameter. Typically, I might have already explained this, but typically for traffic in both directions, you would use 2 smaller tunnels, but they just wanted to use 1 tunnel. And so this diameter allowed them to stack the traffic on top of one another. And so once the boring machine was through, and once it had built a giant circle under the earth, there was a giant form set up that came and slid along the tunnel alignment that then allowed workers to pour concrete for a service area at the bottom, for the first, one direction of traffic at the first level, and then above that, the second level of traffic towards the top of the tunnel. And then at the top of the tunnel, you had further utilities and ventilation, all within one hole. So that is the Wikipedia article. And then finally, to just summarize here, there's an article I found called Retracing Bertha's Journey from the Tunnel Business magazine online by TBM staff, dated February 13th, 2019. And it has the background and everything we've already discussed. But to summarize the timeline and then some of the specs on the machine, because the machine itself was pretty spectacular. So Bertha arrived April 2013. Mining begins at the end of July 2013. Mining stops December of 2013. Tunnel construction halts as between May of 2014 and November of 2015. And December 2015. So it stopped in 2013 December. It doesn't start again until 2015 December. Passes the halfway point in fall of 2016, and then breaks through the northern portal 2017. It is opened in 2019. Again, the original date was 2015. So the fact sheet, some of the specs on this thing. Distance tunneled was 9,270 feet. Tunnel rings built, 1,426 rings. Soil extracted from beneath the surface of Seattle, 900,000 cubic yards. Machine length, 367 feet. Number of propulsion jacks, 56, because it's essentially moved by jacking it against the tunnel rings. Total propulsion jack thrust, 44,000 tons. Total horsepower of motors, 16,500. Mining speed on average, 1 inch per minute. Diameter, again, 57.5 feet. Rotation speed, 0 to 1.2 revolutions per minute. And total crew members required to maintain and operate Bertha in a day, more than 100. Wild. Fun fact, got to go inside Bertha, the tunnel boring machine, in 2016. I was visiting a friend of mine in Seattle. We told them the tunnel, WashDOT actually, we told them that we were doing a college project on the tunnel. And this was after the dramas. So the machine was, I think, moving swimmingly by this time. And we got to go tour the tunnel, go inside the boring machine, go up to the cutting head, but you can't really see the cutting head because it's under pressure. And it was quite spectacular. Tunneling is amazing. We do it all over the world, primarily for utilities and for metro systems. But like in this case, we also do it for traffic time to time. We don't do it as much as some other countries do it in the United States. There's plenty of tunneling in Asia, Australia, Europe. And speaking of tunneling in Australia, we published recently a video on the Sydney Metro project, where we actually went inside of a earth pressure balance tunnel boring machine, a smaller machine, but still a substantially sized tunnel boring machine. And we explain exactly how it works and how they build the tunnel. So if you want to learn more about the tunneling process and about tunnel boring machines, check that out. You can search my name, Aaron, Aaron Witt, Witt on YouTube to watch now. And if you have any other ideas of projects we should feature, you can write us anytime at dirttalk@billwitt.com. We would love to hear from you. I would love to hear what you're interested in, and I want to research what you think is cool. I always appreciate tips. So as always, thanks for listening. And we'll see you next time. Stay dirty.